All right, this is our Trig Unit 1 review. We've covered 8 total topics in trigonometry, and we're ready to start tackling the next unit. But first, we're going to have a little assessment here to assess how you guys are doing with trigonometry so far. And this will give you a chance, hopefully, I know last quarter was last quarter, but it'll give you a chance to make up how maybe some mistakes you did on that last test. So here's kind of the 5 main things to make sure you're able to do. The first is solve right triangles, whether they be special triangles or non-special triangles. You need to be able to find all the angles and all the sides, and we prefer exact values, but you should be able to know how to use the calculator to get approximate values as well. Solve word problems involving right triangles. Remember that if it's a word problem, somewhere in that word problem is a right triangle. Find the right triangle we're talking about and use trigonometry to help solve for the missing values that we need. Number 3 is finding trig functions of any angle from a given point on a terminal side. So if I give you a point, you need to be able to determine what quadrant that point is in, find all the trig functions of that angle based on drawing your triangle, and then you also need to be able to find the angle as well. Using unit circle to find trig values at any angle or coterminal on the unit circle. So if I expect you to find the exact value of sine of 1,125 degrees, that means it's probably coterminal to an angle that is on the unit circle that you can find. Also be able to use identities to find all 6 trig functions, and that is what we've been working on just the last couple days, so that should be fairly familiar with you. So let's do a couple of examples here. The first example I would like to do, I don't know if we need to spend a ton of time on that first one about solving right triangles. Hopefully you guys are pretty good on that. I will do one problem here, one example like this, so let me draw it, and then if after I present the problem, if you want to hit pause, you certainly can go and try to solve it on your own. So if I have a right triangle here, and I do mark this as a 30, 60, 90 triangle, and I tell you that this edge across from the 60 is 17, go ahead and find all of the remaining functions, or all the remaining sides. So if you want to go ahead and hit pause, do that now. Other than that, I'm going to start showing how to do it. Well, first off, you have to remember that in a 30, 60, 90, the hypotenuse is always twice x. X is always the short leg, and x radical 3 is always the long leg. Therefore, 17 is what I'm currently calling x radical 3. So therefore, to solve for x must be 17 radical 3, I'm sorry, x must be 17 over radical 3, which of course I don't really like, so I'm going to write that as 17 radical 3 over 3. So that means that my value over here for x would be the 17 radical 3 over 3, and this would simply be double that, or 34 radical 3 over 3. So those would be my values for the remaining two sides. And it's important to understand the idea that we should know, for example, you should know based on either looking on your unit circle, or I would hope that you would know it, what sine of 60 degrees is. And we can actually use any 30, 60, 90 triangle to determine that. So sine of 60 degrees would be the opposite 17 divided by the hypotenuse, 34 radical 3 over 3. So I gotta say, well, I got a lot of reducing here. So let me take 17, instead of dividing, I'm going to multiply by the reciprocal, 3 over 34 radical 3. And a lot's going to happen here. First off, the 17, the 34 are going to reduce. So I get 3 over 2 radical 3. Now I'm going to multiply top and bottom by radical 3. And I get 3 radical 3 over 6. But of course, this could be reduced. The 3 and the 6 reduced to radical 3 over 2. So there is sine of 60 degrees. Sine of 60 degrees is radical 3 over 2. And guess what? If you look on your unit circle right now, you should see that it's 60 degrees. The sine value is radical 3 over 2. So that would be pretty easy there. Okay, so hopefully you can do that problem. All right, let's take a look at a word problem. I know you guys really hate these bearing problems, so I'm going to give you one of those here to just kind of annoy you. Let's say that we're a ship and we leave port right here. Here's port. We leave port and we go 30 miles due east. So we travel to the east. And then we change our bearings, okay? We change our bearings. We're going to change our bearings and we're going to go in the northeast direction. We're going to go northeast 32 degrees. So that means that east of north, this angle right here, would be the 32 degrees, and we're going to travel that way for 22 miles. And my final question to you would be, how far away are we from where we originally left, how far in a straight line away from where we left. So the idea is we need to make some right triangles here. So if I drop this down and over, I can make this right triangle right here. And why do I like this right triangle? Well, I know the hypotenuse of this right triangle, and I'm going to try to emphasize it with this blue right here. The hypotenuse right here is the 22 miles that I traveled, so I know that's 22 miles. And I also know that if this angle is 32, then 90 minus the 32 means that this angle right here would be 58. So if you want to go ahead and try to start solving this on your own, you can, see if you can get it right. I'm just going to continue going ahead with the problem. So the first thing I need to do is looking at this overall big triangle, the side I'm looking for, I'll call it x, is the hypotenuse. So in order to find that, I need to find the two legs. So let me find this short leg right here. So that would be doing sine of 58 degrees would equal that short leg A over the hypotenuse 22. So I know that A would be 22 times sine of 58 degrees. So 22 times sine of 58 degrees would be 18.66. So this side right here is 18.66 approximately miles. Now I also need to find this entire bottom side. I know that part of it is 30 miles, but I don't know this part right here. I'll call that B. So I know that cosine of 58 degrees equals the adjacent B divided by the hypotenuse 22. So B therefore would be 22 times cosine of 58 degrees. So I can do 22 times cosine of 58 degrees and get that this side down here is approximately 11.66 miles. So now that I can go ahead and use the Pythagorean theorem here, I know that x squared equals the entire bottom leg, which would be approximately 41.66 squared. Again, 30 plus 11.66 would be 41.66 squared. Plus this short leg here, 18.66 squared. Now, if I really wanted to be a little bit more exact, I could actually do 22 sine of 58 in parentheses squared, and then I could do 30 plus 22 cosine of 58 in parentheses squared. But we could probably get a good enough answer if we just do this. 41.66 squared plus 18.66 squared gives me x squared equals 2083.7512, but I'm just going to store that and then take the square root of it to get x. So I would end up taking the square root of that number. Again, it was like 20,083 point something. Take the square root of it, I get about 45.65 miles. So nice easy problem there. Hopefully you understand that. There probably will be something like that on the assessment as well. Another example I want to take a look at, I want to do some practice examples where I ask you, or I give you something like this. I tell you that sine of an angle is 2/7. Now, I could ask you, again, this could be like a problem we did in class just recently. I can ask you to find all the remaining trig functions. So you can go ahead and find cosine, cosecant, secant, tangent, cotangent, and all the different formulas we've talked about. But I want to focus on, I think that you guys should be pretty good with that. We learned several different ways you can do that, but I want to focus on finding theta here. So first off, you have to really think what quadrant I'm in, okay? Because it says sine is positive, which means I'm in quadrant 1 or I'm in quadrant 2. I can never be in quadrant 3 because signs are negative down there, and I can never be in quadrant 4 because signs are negative down there. So basically, there's two different options for alpha, or for theta here. Sorry, I keep saying alpha, theta. Literally, there's two different options. If I use my calculator and I do the old inverse sine of 2/7, then I get one option right away is 16.60 degrees. Now that obviously is, let me get a different color here. Obviously that is in quadrant 1 right here. Here's that 16.60 degrees. So if I'm in quadrant 1, you know the answer right away. It's very simple. However, what if I'm in quadrant 2? So it would be the mirror image of that angle over here, where it would go whoop. Now, how can I find that angle? Well, it's really simple because they're connected by the reference angles. So if that reference angle right here is 16.61 degrees, then this angle right here would be 16.60 degrees. Sorry, 16.60 degrees. So these reference angles here would match up. So now I just got to think this entire angle would be 180, take away that 16.60, and I would get 16.60, yes. Sorry, I would get the 163.4 degrees. So that would be the other option for theta. Okay, I could do another very similar problem here. Just call this number 4, where I say that, hey, tangent of an angle is 18/5. Okay, now obviously it's positive, so we got to think about where is tangent positive. Tangent is positive in quadrant 1 and quadrant 2. In quadrant 2, I'm sorry, what am I talking? This is quadrant 3. Sorry, I'm not thinking there for a second. In quadrant 1 or quadrant 3 is where tangent is positive. In quadrant 2, tangent is negative, and in quadrant 4, tangent is negative. So tangent's either going to be in this quadrant or in this quadrant. So if I pull the old inverse tangent of 18/5, I get that tangent, or I'm sorry, that theta is 74.48 degrees. Now that, of course, is up here somewhere in quadrant 1. That right there is the 74.48 degrees. But that is an option, but there is another option for theta, and that would be the same angle down here, straight across, or mirrored across. It's not perfect mirror there, which would go all the way like this. And what's the connection between these two angles? The reference angle. And the reference angle right here would be the 74 degrees. And that means this reference angle right here would be the 74.48 degrees. So to find that big angle over in quadrant 3, I'd have to do 180 plus the 74.48 degrees. And I get that the other option would be 254.48 degrees. So hopefully that makes sense. Hopefully you kind of start to utilize those strategies in order to find the different values for theta, and you can actually find the exact one that I'm looking for. Okay, let's move on here. I also want to take a look at a couple problems where I ask you, hey, I say find the exact. Now, if I say exact, I'm telling you use your unit circle. Find the exact value of sine of negative 420 degrees. Well, I don't see negative 420 degrees on my unit circle, but I do know that it's probably coterminal, else Mr. Princhuk wouldn't be asking me for the exact value. So take negative 420 degrees and keep adding 360 until you get an angle that you do see exactly in your unit circle. And I added 360 twice, and I got 300 degrees, which basically means that there is no difference between negative 420. Well, I take that back. There is very little difference between negative 420 degrees and 300 degrees, according to the unit circle at least. So if I look on the unit circle at 300 degrees, the sine value, which is of course the y value, would be negative radical 3 over 2. Another example I could do is I can find, find the cosecant of 1,125 degrees. And again, if I just asked for an approximation, you could certainly use your calculator, but I did ask for an exact value. So I'm going to have to subtract 360. 1,125, subtract 360 several times probably to get to an angle. I find out that there's very little difference between that and 45 degrees in terms of the unit circle. So cosecant, remember, is 1 over the y. So I got to do 1 divided by the y value, which is radical 2 over 2. So dividing by is basically timesing by the reciprocal, so I get 2 over radical 2, which of course I don't like, so I'm going to multiply by the radical 2 to get 2 radical 2 over 2, but the 2's cancel, and I get a nice simple radical 2 there. Let's do another one here. Let's do cotangent of 630 degrees. So again, if I'm going to find the exact value, it must be on the unit circle. So keep subtract. I subtracted 360 one time, and I got 270. So that tells me that 270 degrees and 630 are a lot alike. So let's see here. Cotangent, remember, is the x divided by the y value. So according to the unit circle, the x is 0. The y is negative 1. So when I divide those, I just get 0. What do you know? Nice simple answer there. We could also do, let's see here, tangent of negative 570 degrees. So again, negative 570 plus 360 plus 360 plus 360. I end up getting 150 degrees. So there's very little difference between negative 570 and 150 degrees. So remember that tangent is the y divided by the x. So let's see here. Tangent would be 150 degrees. Tangent would be the y, 1/2, divided by the x, negative radical 3 over 2. So I get 1/2 times the reciprocal, which would be negative 2 over radical 3. 2's cancel. I get 1, negative 1 over radical 3. I don't like that, of course. So I'm going to multiply top and bottom. And I get negative radical 3 over 3. Okay, so hopefully those problems make sense. We've done plenty of problems where you've been asked to, given a value, find all the remaining trig functions. Hopefully those, are starting to just kind of wear on us by now. But hopefully those should be easy. Let me just do a quick example with you, though. I would like to give you a chance to practice one. So if I tell you that cosine of alpha equals negative 3/11. Let's make it a fun one here. Find the remaining values. And I would have to also tell you some type of hint. Sometimes I'll just tell you what quadrant you're in. I'll be nice. But for this problem, I'll tell you that you know that tangent is greater than 0. So let me think what quadrant I'm in here. If tangent is positive, I'm in quadrant 1 or quadrant 3. But I do know that cosine's negative, and that would only happen in quadrant 3, at least if I had to choose between 1 and 3. So right away, I know that secant of alpha is negative 11/3. So that's 2 down, 4 to go. I can go ahead and use the idea that cosine squared, 9 over 121, plus sine squared of alpha equals 1. Again, I just did 9 over, or 311 squared, 9 over 121. So sine squared of alpha equals 1 minus that, so that would be 121 minus 921, and I get 112 over 121. And then, of course, you have to square root, and when I do so, the bottom is easy. That's just 11. And then I just got to determine, can 112 be divided by 4, for example? Or actually, I believe it's divisible by 16. Yeah, 16 times 7 is 112, believe it or not. So I would get 4 radical 7. And I am in quadrant 3, so that would be negative. So there's sine. That's number 3. I could find cosecant real easy. Let me do a little bit of dirty work to the side over here. It'd be 11 over negative 4 radical 7. Multiply by the radical 7, and I get negative 11 radical 7 over 28. 4 times 7, 28, yep. So cosecant would be the negative 11 radical 7 over 28. Now at this point, there's tons of different ways I can find tangent and cotangent. I could use the secant, I can use the cosecant to find cotangent, or I could just do sine divided by cosine. So if I do sine, negative 4 radical 7 over 11, divided by cosine, negative 3/11. So the first thing I notice is that the negatives are going to cancel and give me a positive, which I knew. And let's see, 4 radical 7 over 11 times the reciprocal, 11/3. The 11's cancel. And I find out that my fifth answer is that tangent of alpha is positive 4 radical 7 over 3. That gives me one more to find, and that would be cotangent. And if I flip that over, I get 3 over 4 radical 7. And let's see here, that's going to be 3 radical 7 over 28, I believe. So works out fairly nice there. So hopefully it's not too bad of a problem for you to work on. Other than that, guys, honestly, just make sure you please look over your test. Really make sure you are able to understand the angles and the reference angles and coterminal angles and all that kind of fun stuff, because the test, the assessment is going to make you think a little bit. It's gonna challenge you, but it's not going to be anything different than problems that we've done already. So good luck. Practice over things, look over things. Most of your quiz scores were pretty good, outside of a couple people that didn't reduce something or missed a negative here or there. So keep working, and I will see you guys on Monday.